corner solutions already. The composite good, what this does is it lets us put all other goods on one of the axes. So now we can talk about good A and what we'll do when the price of A changes or when income increases, and compare that instead of to another good, good B, all other goods that we might possibly buy. And so the price of all other goods that we might possibly buy, we simply call that $1, right? And then we can use that with our indifference curves again to find the consumer's optimal choice. It's the same as setting the marginal benefit equal to the marginal cost, or setting the marginal rate of substitution equal to the price ratio. Then we broke down a change in the price of a good into two different effects, right? And the price of a good becomes cheaper when a good's price decreases. There will be two effects. One will be a substitution effect, and you will substitute toward that good because it has become cheaper. And then there will be an income effect, which means that when prices go down, effectively you are richer. And so you become wealthier when prices decrease. So the income effect, this is the one that can move in either direction. You become richer if the good is a normal good. The income effect will also be positive, like the substitution effect, and you will buy even more of the good. If the good is an inferior good, the substitution effect will still lead you to buy more of that good, but the income effect will now lead you to buy less of it, because it's an inferior good and you're wealthier. And then an extreme case of an inferior good, one of which I could not give you a solid example, because I don't really know of one that is universally agreed on by economists. But this is a Giffen good, and it's a good where the demand curve slopes upward. So because the income effect dominates the substitution effect, this means that a price increase will lead you to buy more of the good, and a price decrease will lead you to buy less of it. This is so unrealistic that we just don't have a decent example. Yeah?
Wouldn't that be like perceived value? Like, let's say Lamborghinis, they changed one small feature and then they're charging another $100,000 for it. Do you know what I mean? Like, I think
So
that has to do with perceived value.
We do have to keep the quality of the goods constant. And so one that we've talked about before is art. And so the perceived value of art, a lot of times you'll get what looks like an upward sloping demand curve for art, right? Nobody was willing to buy it for $100, but now that it's selling for $1 million, people want to buy it. But remember, we've got to keep everything else constant, and what we're not keeping constant there is either the quality of the good or tastes and preferences. And so,
But it's also an existing good, so you're considering time as well, right?
right. And so we can look at, because most painters never get a decent price for their paintings while they're alive, right? It's very profitable to die when you're an artist. But so all we see is this. We see when the price of the painting is $100, that maybe the artist can sell 2 paintings. And then let's say the artist dies, and now it's $1 million, and the rest of their collection gets sold, which we'll say is 30 paintings, something like that. Part of us wants to just draw a demand curve here that's upward sloping, but really what's happened is that the demand was here, right? And then there was an outward shift because of tastes and preferences or something else. And this is the simultaneous, the problem of simultaneous equations in economics. You're never, when you look at a point, you're not just looking at a point on the demand curve, you're looking at a point where supply and demand cross. And so you're always seeing the intersection of 2 equations, and the only way you can properly try to draw those lines is if you hold one of the lines constant. And that's really, really difficult to do. So that's why we have our ceteris paribus. surplus, right, where we're holding everything else constant. Because it could look like an upward sloping demand curve if we were naive about what it was we were actually observing, but we are observing where two simultaneous equations cross. And so we see that this is a shift in demand, not an upward sloping demand curve. So again, this is why it's so hard to come up with the Giffen good. All right. Then everybody should know how to calculate the consumer surplus triangle, right? The area of a triangle is 1/2 the base times the height. That you should all know. There's definitely a question on this, right? Where you have to look at a graph and tell me what the consumer surplus is. Price elasticity and the price consumption curve. Remember that if the price consumption curve slopes downward, it's a normal good. If it's horizontal, it's a, I'm sorry, I'm wrong here. Price elasticity. If it slopes downward, the price elasticity is elastic. If it's horizontal, it's unit elastic, and if it slopes upward, it's inelastic. And then we talked about two different types of network effects. These are both the fact that the consumption pattern of other individuals can affect your consumption pattern. And this is that you don't want to be on a social network that doesn't have anyone on it. You don't want to have a cell phone if you can't talk to anybody else with a cell phone, right? So the bandwagon effect says when there are more people using a good, then you are more likely to use it, right? Can send you back in time 500 years. Bringing a cell phone with you is not going to do anything because there's no one to talk to. The snob effect goes the other way. This is that you want to do less of something when more people do it. So you don't want to go to the swimming pool when it's crowded, right? Because then you can't swim. There's too many people in the pool. You don't want to go to the amusement park on the nicest day of the year because you're going to stand in line all day. Right? And then the snob effect, right? Maybe you don't want to go to a restaurant that's overcrowded. Maybe you don't want to go to a party with too many people at it. Right? This is all the snob effect. All right. Then we've got extensions of consumer choice. We talked about two different ways the government can increase the purchasing power of individuals. One is through an excise subsidy, right? They can subsidize each unit of a good, which means that the unit price will be lower for the individual for however much that individual wants to buy. The other possibility is a lump sum transfer. Government can simply send everybody a check, they can spend it on whatever they want. We think that a lump sum transfer increases utility more than an excise subsidy does for most people. For all people, really. There are some extreme exceptions to that, but for what we saw, people would much rather be handed cash than vouchers or coupons, right? Because then they can spend the cash on whatever they want. Deadweight loss in these two cases, that can be calculated. Again, deadweight loss is always a triangle, right? At least in all the examples we've done. We talked about school vouchers a bit and what that can do to increase the efficiency of a publicly provided good like education. Then we changed our model to now include two different time periods on it. And that was the intertemporal choice market. And now we had to make a choice not between two goods, but between consumption in two periods. So we were now choosing to consume now and next year, and we were making trade-offs between the two. And we had knowledge of what our income was going to be in this period and next period. The endowment point matters to show on the graph where it is you start from and the transaction you make to change consumption between two periods. But what we saw was that the endowment point, it makes no difference where you start as long as the endowment points are on the same budget constraint. You will still choose the optimal consumption point, which is where the indifference curve and the budget constraint are tangent. The slope of the budget constraint is the interest rate. And then we talked a little bit about investing, and that the expected return you get on a good, it's not going to be the guaranteed return that you get, but your average return for an investment that you make, you'll have to be paid a higher expected return if the risk involved with that investment is higher. And that's because risk is a bad and expected return is a good. So if you're going to give me more of a bad to keep me just as happy, you'll have to also give me more of a good. This is why stocks, while riskier, have a higher expected return than bonds, which are less risky. Right? Then we talked about 3 different types of individuals: risk averse, risk neutral, and risk preferring. Risk averse is the most common type we see. Only risk averse people buy insurance. They're the only ones for them it's worth paying for insurance. Risk averse people, the only qualification somebody needs in order for them to be risk averse is that they have to have diminishing marginal utility of whatever the good is we're talking about. So if they're insuring their income, they have diminishing marginal utility of wealth. If they're insuring their house, that might be considered wealth too, but we could talk about diminishing marginal utility of living space or something like that, right? So whatever you insure, you're risk averse in that good if you have diminishing marginal utility. Insuring your health means you get diminishing marginal utility of health, right? Risk neutral people, it makes no difference to them. They get the same amount of utility from gaining 1 unit of a good as they lose from losing 1 unit of the good. So their utility is constant. It does not diminish over the quantity of that good. And risk preferring people, they get more utility as you keep increasing the good. And again, this risk preferring is typical of problem gamblers, right? They'll take bad bets, but that means problem gamblers are rational. They're making bad bets, but it's because making bad bets makes them happy.